you should have finished your heating curve and you should have your graph all done. Even if you didn't get to the questions, that should be done. Okay? Then, what we're going to do today is we're actually going to look at the heating curve water. Basically, the heating curve that if you had the best lab that you can get, what you would actually get. Okay? So, what we're going to do is we're going to take some notes, which basically is going to be a graph. If you look, you have it set up as Cornell notes. This is supposed to be on page 33. You're going to have your questions here. You will end up with a summary down here. The heating curve notes is really just looking at the heating curve. Okay? So you're going to have your X, Y axis because we're going to put a couple things in there in just a second. So by the end of this period, you should be able to answer the essential question, which is what are similarities and differences between your lab heating curve and the actual heating curve. And you need to really think about a step further as in why do we see, because you'll see that they're a little different, why are they different? So that's like the higher level thing is why is it that it's different? Okay? So, in this case, these notes really do need to be copied exactly like I have them because it is a graph. It's basically you've copied a graph. So you do want to copy everything that's on the overhead. Alright, so you have the X and Y axis already drawn, right? So what I need you to do is I need you to go ahead and copy what I have here. So when you have a line, you want a line that goes up, over, and up. At this line, I want you to have over here for temperature a little box because we're going to have a number for that. At that line, another box because we're going to have a number for that. So you want to go through and actually copy them. We'll discuss here in just a second. Okay. So as you're copying, you really need to pay attention to the fact that you have your x-axis over here. You're going to have an arrow going from the left to the right that says heat added, specifically energy. Okay, you have your arrow going, increasing from the bottom up. That's temperature. I want you to put degrees Celsius because that's what we're talking about. Remember when we look at measurements in science, we always measure in metric units. The metric unit of temperature is Celsius. I know usually we think of temperatures in Fahrenheit, but when we're in science, bless you, we will be doing Celsius. You will have an A right here. Make sure you label it A, B, and C. So I'm going to give you about a minute. It really shouldn't take you more than that to finish that up, and then we'll start discussing. So as of right now, if you're looking at this graph, does it look exactly the same as your graph from yesterday? No. Can you tell me some differences that you see right away, this one to the other one? Yes?
Yeah, the little goes up and down.
The other one goes up and down, okay? Again, was that yours?
Yeah.
Okay. Any other differences? Yes?
Instead of being the rescue point, they usually curves.
Okay, so you saw more of a curve? Okay? So, if you look at this one, does this one look like a curve?
No.
No, the other one did, right? The one you did is curved. This one is a lot more specific. And we're going to discuss here in just a second. Okay, so let's go ahead and get started. So one of the first things that you need to pay attention to is that heat increases from left to right. So this is an increase decreasing line. So you're adding energy, okay? So what type of energy is increasing from left to right? Kinetic, very good. So kinetic energy is increasing from left to right. So kinetic energy is increasing from left to right. What's happening to potential energy? It's decreasing because kinetic is always an inverse or opposite from kinetic. Alright, so then you look over here. This is your temperatures in degrees Celsius. So what's happening to the temperature here? It's increasing. Now, what does A stand for? A solid. How do I know that's a solid? They're compacted, and are those particles not moving at all? They're vibrating? Everybody show me what they're doing. With your body, what they do? Come on, I want to see it, I want to see it. Right? They're just vibrating, very good. That's what they're doing, alright? Now, B is the what?
Liquid.
Liquid. Okay? So, if solid is a solid because they're really compacted, why is liquid a liquid?
Because they're not too far
They're
apart.
sliding
They
past
have to
each
go
other.
around and get more.
So they're not too far apart, they can move around. Now with your hands, show me what they're doing. So just kind of moving, right? Just a little bit, right? Your hands aren't getting too far apart. Alright? Then C is a gas. What is that doing?
They're getting separated.
Separate. They're moving all the way around. I want to see you guys in the back. Wake up. There you go. Thank you. Alright, so you're going from a shake to a little bit of movement to a lot of movement. What would a plasma look like?
Everywhere.
It'd be like, right? So all crazy. That's what it would do because it's moving so fast. It has so much energy. Okay? So, out of this heating curve, you obviously need to know solid, liquid, gas. Okay? We talked about characteristics. Now, we're talking about specific processes. So if we look at arrow 1, that arrow is going from a solid to a liquid. So what process is that? What is happening to the solid? Solid to liquid?
Oh, no.
Melting.
Melting. So this stands for melting. So from a solid to liquid is melting. And what's happening to the energy again?
Less kinetic.
Kinetic's going up,
Potential.
potential going up. Okay. Alright? Then if I go from a liquid to a gas, what's that doing?
Evaporating.
Evaporating. Okay, what's happening to kinetic energy?
It's going up and
It's going up. And potential is going down. Okay. Alright. Then I come over here to number 2 here. I'm going from a liquid to a solid.
freezing.
Freezing. What's happening to kinetic?
It's going down.
It's going down and potential is going up. Okay? Gas to liquid.
Condensation.
Condensation. What's happening to potential?
It's going up. No.
Okay, potential's going up, kinetic's going down. So make sure that whenever you get those questions, you pay attention. Is it asking for potential or is it asking for kinetic? Because it's going to be the opposite if you're asking for one or the other, right? So you want to make sure you pay attention to those points. Okay. So my kinetic energy increases that way. My potential energy increases from what to what?
From right to left.
From right to left. Sorry, that's not straight, but it's as best I can get it. So, if we look at this one right here, melting, freezing. At what temperature, this is for water, does liquid freeze into a solid?
0.
0. Very good. That's something you need to know. You didn't know it's 0 degrees. Now I know it's crazy. Oh, I have to memorize numbers. Those are just numbers that you're going to come in contact a lot. So might as well know, right? So water freezes, or the freezing point is 0 degrees. Evaporation. So at one point does it start boiling? When does it? Fahrenheit. Oh, we're in Celsius. 100. Okay, so we're doing 100 degrees is boiling. So 0 is melting, 100 is boiling. Are those the exact numbers you had yesterday?
Yeah, we had 99.6.
What was yours?
99.6.
99.6. Okay, I don't know what was yours? 100. Yours was 100. Okay, and what was yours? 100.1. Okay. Who had a different one than those three? Yes. No. 99.4. 99.4. Okay, so didn't we all use the same type of ice? Isn't ice from water?
Yeah.
Why is it that we didn't all get straight 100? Okay. What's in the water? Different chemicals. So, do you think about it? If you have pure water, it's just H2O, right? That's all it is. Those are the only properties you're going to have. Correct? Okay. So, I take some water from the tap. That water in that cup, then I take another cup of water from that same tap. So 2 waters from the same exact tap. If I looked at the chemicals, would they be the exact same chemicals in the exact same amounts? No.
They'll be different.
They'd be different. Even though it's coming from the same place, right? But because it's a mixture, you don't get the exact same amount all the time, right? That makes sense. Think of it. You have a salad. Is one of your spoonfuls or forkfuls the same exact as the next one? No. Okay? Sometimes you might get a piece of tomato, sometimes you not. Sometimes you might get some curds, sometimes you won't. Right? So that's why. Because the water that we used was a mixture. It wasn't a compound because it wasn't pure H2O. So because it has a bunch of stuff, it could be that yours had a little bit different stuff than the other one. Okay? That's why very few of you got even to 100. So, as I was walking around, a lot of you started seeing bubbles like at 96, 98, right? Okay? Reason for it is because it has other stuff, which that other stuff in there has lowered the boiling point. Okay? Because those other things in there boil faster than water. That's why. Okay? Alright. So, any questions over this? So, what you're going to do eventually, not right this minute, you're going to look at this and you're going to compare it to the one that you got from the lab. Okay? In your question sections, I want you to come up with some questions that compare both of those. Okay, so your questions don't just have to do with these notes. I want your questions dealing with these notes and your lab. So I want you to kind of put those two together. Okay? In your summary part, basically what I want you to do is I'm going to want you to answer the essential question. What are similarities and differences and why? And we just discussed them right now. Okay? So what are some similarities, what are some differences, and why? Okay? Now, does that need to be done right this second? No. But eventually, that's what needs to be done with these notes. Okay? Any questions over any of that? Okay. Now, surprise, surprise, you have a test. It's a CPR. Okay? So, I need everybody to clear your tables. You need a pencil.